Hi, my name is Michael Lavara, and welcome to Part 4 of Paint and Materials Effects Testing with 100 low lead and G100UL. This one I've titled Truth and Transparency. And if you haven't seen the previous videos on this topic, they're linked in the description below. So what's in this video? There's some industry updates. I'll talk about affected aircraft and G100UL sales volumes, the CEH lawsuit and legal declarations, updates from affected aircraft, including one I had not previously discussed, a new aircraft, rubber gaskets and goo, and STCs. There have been several more statements in industry about the use of G100UL or non-approved fuels. Cirrus reiterated its statements about use of G100UL on its aircraft and mentioned that their service advisory calls that out. EAA also highlighted that there's field reports and the need for owners to assess their experimental amateur-built aircraft prior to using G100UL. They noted specifically that testing protocols for STCs are proprietary, and to date a list of materials tested has not been shared with owners or operators. Lastly, Piper Aircraft came out with a statement regarding unapproved aviation gasolines in their aircraft, and they noted that G100UL was not approved for use in their aircraft. So let's talk about the affected aircraft and total fuel usage of G100UL. GAMI has stated that about 130 aircraft have used G100UL. One G100UL consumer obtained via a FOIA request fuel usage for Reed Hillview and Watsonville. Digging into the numbers, as of late February, Reed Hillview had sold about 5,200 gallons of G100UL, and Watsonville had sold about 2,800 gallons of G100UL. So collectively, that's about 8,000 gallons sold and used by about 130 aircraft, which results in an average of about 62 gallons per aircraft. I'm aware about 24 aircraft noting negative observations and issues since they've started using G100UL. If the 130 aircraft total is accurate, then the 24 aircraft reporting negative observations is about 18% of the total usage. I think that number is statistically significant. I wanted to point out the Center for Environmental Health lawsuit, which lays a foundation for many of the declarations I'll highlight in this video. In short, it goes back to 2011 with the settlement agreement in 2014. Those FBOs and fuel distributors being sued agreed to distribute an unleaded fuel when it was available. CEH sued to enforce the settlement agreement in December 2024, but now wants to amend the settlement agreement to essentially ban 100 low lead in California, which would make G100UL replace all 100 low lead at these FBOs and virtually all of California. In response to this motion, some of the affected pilots with aircraft experienced difficulty and damage due to G100UL have filed declarations stating their experience with the fuel. So I want to take a look at some declarations from both those advocating for G100UL and from affected owners and mechanics. The first declaration is from George Braley, the head of engineering for GAMI, and he points out all the features of G100UL, but also takes a swipe at Mooney aircraft, saying they have a unique and inadequate type of fuel tank construction as compared to standards for other certified aircraft in the industry. The second is from Paul Milner, a retired petroleum engineer in the Bay Area, friend of George Braley, and the president of a little-known association called Aircraft Pilots of the Bay Area located in Oakland that I've never heard of. He's advocating for the rapid and widespread deployment of G100UL avgas at all the airports in California in the shortest time possible. This filing is on behalf of the settling defendants, who added additional reports of evidence of aircraft that have been affected. Herein, numerous pilots show the reports of damage to their aircraft, and also one FBO comments that they cannot use a non-ASTM approved fuel without voiding the tank's warranty. I'll take several of these declarations and dig into them, showing you photos of the affected aircraft in the following sections of this video. The next declaration is again from Paul Milner, who submitted this additional one after visiting several of the affected aircraft along with George Braley in early February. I want to point out that both he and George Braley are blaming aircraft design and maintenance, and not the use of G100UL for the problems that users are experiencing. Based on what I've observed and heard from owners who use the fuel, not everyone desires to be mandated to use G100UL. A Cessna 180 owner in the Healdsburg, California area filed a declaration stating he experienced staining of paint, increased EGT spread, and some discoloration in his car bare box. After getting the STC on November 2nd at Reed Hillview Airport, he goes on the declaration to denote that he had some seeping fuel that stained the fuselage and the wing on the aircraft, which took some work to buff out. Along with that, he noticed some performance issues related to the EGT spread in his 0470U engine, and also some staining in the carburetor and airbox area, which he had not noted before. I'll scroll down here, and you'll see he took a picture with George Braley on the day of the STC day, followed by some of the other items like the staining on the bottom of the wing and the top of the wing. And lastly, I want to point out the specific issue in the carburetor area. And while it might look normal at the beginning to some, notice the dark discoloration here. Keep these dark stains in mind, because later in the video I'm going to share some observations I've noted when the fuel is left to evaporate in open air for an extended period of time. The owner's observations about his increased EGT spread while using G100UL rang some bells to me. I had remembered reading the PAFI Lessons Learned document where they described the fuel mixture distribution of engines like the 0470U, which are sensitive to this. Those who regularly fly 0470s with the 6-cylinder engine monitor know how difficult it is to really balance all the cylinders on the EGT and CHTs for the engine. This declaration is from a mechanic at Reed Hillview Airport who runs an FBO, and he highlights some issues he's had with the Piper PA32 after utilizing G100UL. Specifically, it's had a couple leaks, and one of them was from the Buna N style gasket around the fuel sender in the aircraft, and the owners had to spend some money fixing it. He also notes that he's had to buy extra personal protective equipment because he's noticed getting headaches when working around the aircraft. And here's a few photos of the damage from one of the incidents where the fuel leaked out of the tank and got some of the paint on the bottom of the aircraft. In the latter part of the declaration, he highlights a Beach Bonanza that's had multiple issues with fuel injectors clogging. And the owner's had like 3 incidents where he's had to go and clean deposits off of the injector of an unknown origin. He stated that it appears that the cork gaskets between the bladder and the wing interface have been compromised somewhat, and he had to go back in and tighten up the screws that hold the access plate to the bladder in order for the leak to stop. The owners of the affected RV6 in Watsonville sent me an update video recently, which highlighted the aircraft in better detail after they started cleaning it. As you can see here, on the bottom of the aircraft, there's some heavily dark stains in the paint, which were not removed with just a regular cleaner. This is consistent with damage that I've seen with any aircraft paint surface that's been subjected to G100UL. Continuing down the belly here, you can see where the fuel had leaked along the flaps and the center of the belly, removing several areas of paint, and also continuing to remove paint in the bottom of the fuselage and the belly underside. And again, when George Braley visited the aircraft in February, he claimed that this damage was not caused by G100UL. This aircraft was painted with a PPG acrylic urethane. One of the owners filled out the following declaration that's part of the CEH suit. And this declaration highlights the experience the owners have had utilizing G100UL. Scrolling down, you'll notice that the conversation they had with George Braley seemed to indicate that he'd like to see the tanks and maybe cover the cost to have them repaired at a facility near him. But when he visited on February 2nd, he said, quote, their wing tanks were the worst he'd ever seen in any airplane, and that they've been unable to show that G100UL permanently damages aircraft paint in their own internal tests of aircraft panels exposed to G100UL. And these owners have stated that they will not use G100UL going forward. The owner of the affected Cirrus at Reed Hillview Airport invited me to look at the aircraft as they had begun initial repairs before the aircraft relocated to a Cirrus service center. On February 18, 2025, I looked at the aircraft along with the owner. And you'll see here the damage that occurred from the aircraft after it had leaked G100UL onto the lower surface of the wing, running down towards the wheel pant area and landing gear leg. Prior to my visit, both Cirrus and the FAA were on site to remove the affected access panel, and it has been taken for further inspection. The damage includes staining to the painted surface and removal of the paint and primer, exposing the lower surface of the wing, which I believe mostly to be the lightning strike material on the Cirrus aircraft. The following declaration was by Patrick Waddick from Cirrus Design Corp., aka Cirrus. Included in the declaration was this document, which was recommendations from Cirrus Aircraft's Field Sustaining Engineering Department on how to return the aircraft to service. My friend Cessna 421 at Reed Hillview, that, as I mentioned before, sparked all this research I'm doing, has had an additional issue pop up. As he's trying to bring the aircraft back to service and inspect it, he noticed that there's a problem with one of the fuel selectors that did not exist previously. Denoted in this video is him describing the operation of the right and left fuel selectors from each side of the aircraft wing. He actually can't get the right selector to move to the left main in this case, which poses a serious airworthiness and safety issue. Detailing the system's operation further, he points out the red lever between the two right and left fuel selectors, which is the emergency crossfeed shutoff valve, and you have to pull this in order to shut off the valve. He has to exert such severe force that he felt that he could not do this while sitting in the chair of the aircraft, and this is not normal for this particular valve. Following this finding, his aircraft mechanic, which performs his annual inspections, filed a service difficulty report with the FAA. This is the declaration from the Cessna 421 owner, where he highlights all of his experience utilizing G100UL and the issues that he's located. I'll note that he points out his experience talking to George Braley and the owner of the Cirrus in early February, where George highlights that he believes all the aircraft that have had issues are poorly maintained. He then goes on to highlight the issues he's noted recently with the fuel selector on the right side of the aircraft, where he cannot adequately crossfeed, and this is a serious airworthiness issue. The owner of the Cessna 421 has been investigating options to repair the wing access panels and the fuel selector, as the aircraft is currently not airworthy. He reached out to Textron and aftermarket gasket companies to look at the wing seal gaskets. Not all the wing seal gaskets are available in "modern materials." And the fuel selector, as designed and built, is only approved for Buna N or nitrile style O-rings. Nothing newer, as George Braley would suggest. And again, if his O-rings that were Buna N or nitrile swelled due to G100UL, he has no way of utilizing G100UL without some sort of field approval or modification to the fuel selector. On February 9, 2025, I was alerted to a second Cessna 421 at Reed Hillview Airport that was experiencing paint degradation and leaks from its lower access panels. The owner of the 421 allowed me to visit his aircraft that same day as he was at the airport. He noted that shortly after introducing G100UL to the aircraft, he had noted several panels started leaking on the lower surface of the aircraft. The owner noted collectively that numerous panels had to be resealed at various stages in time while he's used G100UL, and at this point, he's tired of it and switched back to 100 low lead. He noted to me that he had not had leaks like this on the aircraft prior to introduction of G100UL. I want to note here that while there's both brown and blue stains on the lower surface of the wing near the flap, there's severe paint degradation below the staining. The owner noted to me that he had no paint degradation nor staining of either blue or brown color prior to the introduction of G100UL, and the blue stains only appeared after he reintroduced 100 low lead to the aircraft. Last video, I discussed a Cessna 182 that had a brown sticky goo near the fuel drains on both wings. I wanted to update here what they observed after inspecting, and also ask some questions if this was similar to the AOPA Barron's issues. In this declaration, one of the owners described the observations they noted when they started digging into the aircraft. First, it appeared that both bladders, which were installed around 2020 and 2018 respectively, were expanded in a manner they're not supposed to. They drained the G100UL out of the aircraft, poured 100 low lead, and then found out that it still leaked. Digging into it further, they found that the cork gaskets between the bladder and the wing surface had become degraded and allowed fuel to leak outside the bladders, and consequently apparently eat the chafing tape between the bladder and the wing, resulting in the brown goo. This Cessna 182's issues are very similar to the AOPA Baron, which you see here that has brown goo leaking out of the bottom of the wing. And while GAMI might simply declare this issue is due to old bladders, the Eagle Fuel Cell report doesn't quite say definitively what the exact issue was. They mentioned there's small leaks. There were some loose bolts on the left aux tank. Both right mainsails had a number of minor leaks, and the left mainsail had a loose exterior patch. But they don't know why several gallons of fuel was loosed inside the wing in a short period of time, how much the left mainsail was actually leaking, And more importantly, they question whether the left aux tank was actually leaking at a connection or a gasket, and point out some issues they've seen with gaskets before. More importantly, they point out that everyone was focused on the left main fuel cell, and they did not check the left aux fuel level while it was at AirVenture, so they don't know if it might have leaked from there. They do state that a definitive explanation remains elusive. In my usual quest for the truth, I looked up what the typical gasket is between the bladder and the wing on a twin bearing, and that's this one here, which is typically a cork nitrile style material. Early on, I had questioned what this fuel might do to cork gaskets, but I had yet to test it. There are several cork nitrile gaskets in Cessna aircraft. An example is the bladder to wing access plate, like on the Baron, the Cessna 172 fuel selector, or embedded in the fuel strainers of most Cessna single-engine pistons in the front of the aircraft. So I wanted to observe what happens to these when they're put in contact with G100UL. I was able to locate an old stock of a Cessna 172 fuel selector gasket. On the left is a copy of it, and on the right is the actual part. It was submerged, and as you can see here, expanded within 3 hours of being placed in G100UL. Here I've zoomed in a little bit more over the same time period. While this part is normally clamped in place, I'm not sure that much expansion is really desirable. Here you can see it placed next to the original copy that I had made before submerging it. One of the locations in the GA fleet where a cork gasket like this would be constantly wetted is in the fuel strainer for a Cessna 172, shown here as item 10, just above the fuel filter. Much of the Cessna single-engine fleet are older aircraft, and there's a big aftermarket presence for many components, which have improved many of the materials. Here you'll see 2 gaskets from a fuel strainer on the Cessna 172. These were made by a well-known manufacturer of aftermarket Cessna parts. I placed identical gaskets, each in a container, one with 100 low lead and one with G100UL. And as you can notice here, the 100 low lead gasket sunk to the bottom, whereas the G100UL gasket remains suspended at the top of the surface. And as with the stock Textron gasket, the aftermarket Cessna fuel strainer gasket expanded within several hours in G100UL, while 100 low lead remain unaffected. I then located another circular cork gasket and placed it in G100UL, as you can see on the top left. It swelled within several hours. And on the top right is a 50-50 mix of G100UL and 100 low lead. Again, as noted here, it expanded while the 100 low lead gasket remained unaffected. This experiment certainly raises more questions about material compatibility, especially on items like gaskets at the top of a fuel bladder that might be occasionally wetted and then dried because the fuel tanks are not always full or sloshed when it's flying. Here's the fuel strainer gasket results after up to 3 days exposure. The G100UL exposed gasket had the most swelling. The 50-50 mix of G100UL and 100 low lead had less, and 100 low lead was basically unaffected. And to round out the testing, the circular gasket swelled significantly too. So to summarize, the cork nitrile style gaskets had significant swelling when subjected to G100UL and little to no observable change in 100 low lead, as most of us are accustomed to. The applicable mil standard for cork gaskets allows a 25% volume increase, and a spot check of the fuel selector gasket after 1 day yielded greater than 50%, with a measured increase of 85% after several days. The key point is the long-term effects are not yet assessed, and I suspect we might see something with the wetting and drying of the gasket over time. I want to take a moment to introduce a Grumman Tiger that I've known about for a while, but have delayed reporting on as I've been waiting on more information. This aircraft encountered a stuck valve and a bent pushrod after introduction of G100UL. The local FSDO and FAA are investigating. I learned that Grummans use an interesting bonded construction method, whereas the metal is bonded together with an epoxy on the majority of surfaces with minimal rivets used. A while back I noticed on AvWeb someone commented about this whole fuel issue possibly being similar to the Bertram boat tank issue. There may be a parallel to this with the Bertram boats, but I want to state no official finding has been reported yet. So around early January, a Reddit post came up with a mechanic posting about a potential serious failure after use of G100UL, where the aircraft encountered a bent pushrod, some black material caked on the intake valve for the engine, and the interior of the intake pipe is coated black, something not typically seen. On January 20th, I located the affected aircraft, and it seems to have a really nice paint job on it. I took some photos of the underside of the wing to look for staining, and found a little bit by one of the fuel drains. But overall, the aircraft was in good shape. The aircraft sat on the ramp here at the airport with several of its engine components removed for investigation. On February 27th, I stopped by and took a look at the aircraft. I noticed brown staining on the bottom of the wings and drips on the wheel pants, but notably the fuel drains were gone. I don't know if the aircraft started leaking before the drains are removed, or it's a byproduct of draining the fuel out of the aircraft as part of the investigation. To me, this is another data point against GAMI's assertion that their fuel does not damage or deteriorate aircraft painted surfaces. Pivoting back to the Bertram boat issue I mentioned in the beginning, this was an issue I had little information on, and in doing research was quite interesting. Notes of black stuff building up on valves and intakes, destroying engines, and some fuel tanks are becoming soft after use of ethanol-based fuel. There was tests of black material from an intake valve. There were materials compatibility testing, looking at the fiberglass materials in the boats that were having issues. And they believed that some of the resins, gel coats, and fillers were actually coming apart when in contact with the fuel. This got me thinking about the affected Grumman aircraft and possible parallels. The aircraft is constructed with an epoxy-type resin that bond the skins to the ribs and other structures. And while that fuel tank may have sealant around many areas of it, there could be areas of the structure that are exposed to fuel, resulting in the epoxy possibly being degraded. The interesting thing here is they talked about some of the stuff that dissolved in the Bertram boat issue and actually went through the fuel system, the filters, and into the engine, and then when it went into the intake, turned into this black goo. And if the reports of the FAA investigating this Grumman's issues are true, I look forward to seeing if there's any correlation with the Bertram boat issue and their findings. It's certainly an interesting theory. Pivoting back to fuel remnants and goo and/or stains, I found that fuel exposed to open air darkens, and if evaporated leaves a sticky brown goo. Fuel in an open container with a vent or exposed to light appears to darken. And I started wondering, is this maybe related to the clogged injector reports that we're getting? In my last video, I tested Bonanza louver panels, which had some drip trays below them. Over a several week span, I had applied approximately 48 ounces of G100UL to this panel, and then the remnants of it fell into the drip tray below. I stopped testing on February 4th, and no more fuel was applied to the test panel. These photos were taken on February 8th, February 10th, and February 22nd, respectively. And as I've noted before, I believe these remnants are the high boiling point components of the fuel that do not evaporate easily. The following observations of the tray were taken on February 22nd. This is the residue left over after several weeks of evaporation. And I'll note that the residue here is very sticky and doesn't flow very easily. I decided to take some of this brown substance and apply it to the Bonanza louver panel. You'll see here at 2:30 p.m. I poured a little bit down an area where some rivets were. And then later at 7:30 you can see that the paint had peeled where the substance had been applied. And then scraped away a little bit of the affected paint layers you can see here. And then wiped the surface clean. You can see the final result here is heavily stained and compromised painted surface. So what is this dark stuff? I've long theorized that the highly volatile components evaporate, leaving behind the more aggressive stuff like M-toluidine. Paul Milner posted this on Beach Talk, and essentially he says toluidine itself doesn't like bunanitrile rubbers, of which some seals and bladders are made. But like in medicine, the difference between a medication and a poison is the dose. GAMI's using approximately 3% toluidine with about 10 times as much mixed xylenes. That dilution does a great job of passivating the toluidine, as GAMI's testing revealed. So, if we unpassivate the toluidine, what happens when that material is put in contact with rubbers, paint, primer, sealants, etc.? Seems like the word passivate or passivation is an important part in this, especially with M-toluidine. Because the fuel does certainly seem to turn brown when it's exposed to open air. In a previous video, I shared this SDS sheet with the boiling points for the respective components of G100UL overlaid on it. And obviously, just like nutrition sheets, they say the more items on it, the worse it is for you. I'm starting to really wonder if by removing lead, we've added other things that are hazardous to our health. STCs, are they as easy as 1, 2, 3? I bring this up because the process for applying the STCs to an aircraft has been stated as relatively simple. However, the IA or mechanic that fills out the form should ensure that there's compatibility between the aircraft and the newly applied STC, and that there's no conflicting STCs. With that said, is it really feasible to get 125 aircraft their STCs on the same day with a thorough review of an aircraft maintenance record, reportedly by a single IA? So, some closing remarks. I'm really just seeking the truth of the matter in this situation, and I desire a fuel that is safe to operate and will not damage my aircraft. There is a growing and significant number of affected aircraft after introducing G100UL to their engines and airframes. It is extremely critical that those who experience issues with G100UL report them to both GAMI and the FAA. I'd like to point out that GAMI has still not addressed my findings with Easy Turn lubricant, nor have they addressed my question about if fabric's been tested with their fuel. I suspect they've been quiet lately because they're in the process of trying to litigate their fuel to be mandated in California. After all, we really need transparency in the transition to unleaded fuels. And I'll call on the FAA to investigate all the issues noted if they're not already doing so. Lastly, use of this particular fuel should be a choice, not a mandate. Thanks again for watching, and I've included a bunch of links in the video description, including many of the declarations that I highlighted here in the video.